And I always ask the question, what's the most vapor permeable membrane you can get? Do you know what it is?
No.
Nothing. It's air. You just take the membrane out and the water vapor can go straight. Oh, but hang on. How am I going to weatherproof my building if I've got no membrane in there?
Yeah.
So now you've got this double-edged sword. I need to put a membrane in, but I need that membrane to be as vapor permeable as possible to allow the water vapor out. But also, if I drive the vapor permeability of the membrane too high, then I start to compromise the durability of that membrane. Because you can make them super vapor permeable, and have done this around the world, but they super vapor permeable membranes had massive durability issues, which then in Germany, led to failures of those membranes, which then led to water ingress or failure of the weatherproofing systems, which is actually worse than the condensation problem.
Yeah.
But so this is the double-edged sword.
You know, people also leave behind the thought process of the fact that there's moisture moving or vapor moving from the inside to the outside as well. And if
Mm,
it's going to hit the back of the cladding, where's it going to go? It's going to go straight back into if you don't have that weather resistive barrier with it's got that, the required level of vapor permeability for your
mm,
climate, it's going to go straight back into what's ever within the wall. And that could be insulation, or that could be your timber stud frame, and then just sit there and not be able to dry out because you've created this kind of locked zone for it, that
yeah,
then it's going to, be sort of just hanging out there causing mold and problems and things like that. So I think this is why a lot of homeowners struggle, and industry as well, struggle to kind of consider it, because conceptually we come from a very different mindset about how walls perform and what walls
yeah,
do.
absolutely, yeah.
And, and we built houses that pretty much like tents for a really long time. I mean, my house is, point in case, it was built by a builder himself, that it was his own home. And he was, I think he'd been building for 30 years when he built this place. It is incredibly well built, but for the environment and the thermal performance and the climate, it is not at all. And so it's really interesting to see then, because there's no management of the air movement. It is ridiculously cold as a house in winter. All of those kinds of things have come into play because that's how we think houses still need to be built. So
Mm,
really, it must be really challenging at Pro Clima to kind of disrupt, because you are bringing European thinking, I think, into the way that we build homes, but there's an immediate
yeah.
disconnect of, we don't need it because we've not done that in the past and we're fine. But that whole thing of trying to avoid the leaky building syndrome that Canada and New Zealand have both been through, I think is so imperative.
Yeah, absolutely. It's I've had this conversation of, can you leapfrog the problem, or do you have to
Yeah.
create the problem and then solve it? And you know, it's the problem's always gonna come. I mean, it's there already. I mean, we got some really strong advocates for Pro Clima in the cooler regions of Australia, in Melbourne and Tasmania, because they're in the thick of it. Because when you increase the energy efficiency, obviously you see these problems first in the coolest regions. But when you start increasing it higher, that latitudinal line of pain, if you like, will just start to increase further and further north. So the moisture problem is there, but that European thinking that you're talking about is back to the original question of, why did we do the study? Because that's why we had to do the study. Because, like,
Yeah.
well, actually, this has been experienced, this what I call the cascade of intervention. The cascade of intervention was, you put insulation in your building, you change the dynamics. Oh, hang on, we're starting to create a moisture problem. All right, what are we going to do here? Okay, we need ventilated cavities. Oh, we need vapor permeable membranes. Oh, hang on, that's not enough either. Okay, we need vapor control layers on the inside of the structure, which we haven't got to yet. What an IAB is on the inside of the structure. And oh, hang on, we need to also ventilate the indoor environment to make sure that we've got, lower humidity on the inside, and purge out all the contaminants, and good indoor air quality and all those things. And before you know it, you've gone through this cascade of intervention that actually leads you to something that looks like the five pillars of passive house.
Yeah, and it's funny because people hear passive house and think, I don't want to go that far, and it's like, well, just the merits of it actually are that it is the thing that will help you create longevity and health in
Yeah.
your building. So
And
it's
the only reason I ended up where I am is because I was going, well, if I do that, what happens?
Yeah.
If I do that, what happens? If I do that, what happens? And you go, like you said, you lead yourself through the thinking to something that looks like passive house. Not necessarily passive house, but it might look like passive house.
Yeah.
Because I mean, there's other schools of thought too. It's not just, we'll fully seal, have huge amounts of insulation, have a mechanical ventilation system, and everything will be hunky dory. But there's the older style, naturally ventilate, and do the older solar passive design sort of side of the argument. And there's absolutely nothing wrong with that. But when you look at the statistics on space conditioning in buildings, then you start to go, holy cow, almost everyone in this country has an air conditioner or a reverse cycle air conditioner, and particularly all the new home builds. So do you try and pull down that whole industry of the air conditioning industry and say, hey, no one can have ban air conditioners, basically, and therefore we all live in naturally aspirated, naturally ventilated environments that are comfortable or maybe sometimes uncomfortable? Or you design buildings that are really well suited to be space conditioned, have a much higher level of comfort for a much longer duration of time. And neither of them are wrong. It's just, what's the market drivers that are pushing us down a certain avenue?
Yep. Yeah. Okay. Yeah. That there is a whole can of worms that we could open up. But before, I want to jump into the National Construction Code. But before I do, I just want to close out that. Can you just talk us quickly through what an IAB is?
Yes.
Yeah.
Okay. So we talked about WRB, which is on the outside of the construction system. IAB is, I've actually got somewhere in my archive a whole matrix of what people call these around the world, and it could be, a smart vapor control layer, a smart vapor retarder, intelligent air barrier, vapor check, depending on where you are in the world, US, Ireland, Australia. But ultimately, it's a membrane. It's an airtight membrane on the inside of the insulated framed structure, generally speaking. So that airtight layer also has the intelligent aspect to it, or smart aspect. And that intelligent aspect is that it actually operates slightly differently depending on what the conditions are around that membrane. So in the summer and winter, you get slightly different conditions because you're heating in the winter. So you've got a warmer environment in the winter, and the membrane operates as a high vapor resistance membrane, stopping water vapor going into the wall system, potentially creating condensation. For that to work really effectively, that membrane needs to be as airtight as possible. So that's why it's an intelligent air barrier, because it's got that smart vapor control function, but also it needs to be airtight. So the air tightness, if you have holes in an airtight layer, you potentially get water vapor bypassing or getting a free ride through those holes, and your layer doesn't do what it's meant to do. Then go on the other side of the coin, which is to summer. In summer, you potentially got higher humidity on the outside of the building, warmer conditions, which means you got water vapor going, trying to push backwards into the construction system, into the cooler, drier, air-conditioned environment on the inside. And in those conditions, that's when the intelligent air barrier on the inside actually becomes more vapor permeable. So it actually allows water vapor to come back into the inside of the building to some extent. And the reason for that is because historically in North America and parts of the US, they had tried using just plain vapor barriers on the inside of the structure. And I'm talking about really cheap polyethylene or polypropylene builder's plastic.
Yep.
And what happened then is you get sweating. You get, like, in summer, you end up with these sweating behind the membranes. And the reason the Intello Plus product that Pro Clima sells was developed was to stop that sweating process happening in summer conditions. Yep. So it allows the water vapor to dry back inwards, and gives it much faster drying of the construction system should there be any moisture in that construction system. So yeah, the intelligent part is essentially that ability to be able to change with those differing summer, winter conditions.
Okay. No, that's great. Thank you for that run through. I think that's given everybody kind of a comprehensive understanding of that. And obviously, the conversation about classes. I want to dive into that a little bit around just in regards to the changes to the National Construction Code. So obviously National Construction Code 2022, we've seen some big changes around condensation management.
Yeah.
I think there's been, for the first time, the code's actually explicitly addressing the link between the building construction and human health, and what that, the interplay between the two of them and the issues with mold in building
Mm.
envelopes.
Mm.
You look at the stuff that's online on the ABCB website. They're actually explicitly talking about mold problems and those kinds of things, which I've never
Mm.
seen in National Construction Code presentations before, which is actually really interesting.
Yeah.
Can you take us through some of the things that I know that you are heavily involved in terms of conversations about building codes and things like that. Can you talk us through some of the things that excite you about these updates to NCC 2022, and also where you feel it's still lacking, and homeowners need to be aware of this as they navigate it?
Yeah, I guess as you would be well aware, there's generally two pathways to compliance with the building code. There's the deem to satisfy, sort of just do this and she'll be right, it will work. And then there's the verification method, which is you use a different pathway to prove that your building actually works. And to be honest, the deemed to satisfy in the health and amenity section for condensation management in 2022 is still lacking, because it's talking about vapor permeable membranes, which is a great step in the right direction. But it's really difficult to get a membrane vapor permeable enough to completely eliminate the risk of any condensation or any mold growth behind that membrane. The other pathway to comply
Is that
with
because you need the ventilated cavity as
well,
well? Is
yeah,
that
there's
what you
other
think?
things.
Yeah.
Yeah, sorry. There's a few other things that need to go with that vapor permeable membrane. It's not just, I put a membrane in that has a certain specification and it's all okay. A product itself is not a solution to any problem. It's a system design solution. And that's where the architects come in, because they need that ventilated cavity on the outside of the vapor permeable membrane. If you put a piece of steel cladding up against the vapor permeable membrane, it's not going to do anything. And any monkey can see that, or I hope they can. But so you think about that and go, okay, so I batten that piece of steel off, and now I've got a ventilated cavity, I can get the water vapor out of the system. So that cavity is critically important to it, which is a big discussion point as well in the building codes level and future revisions of the building code. But then even that's not enough, because the vapor permeable membrane itself, it might be class 4, might be class 3, depending on, well, class 4 in the colder climates is forcing you down that, climate zone 6, 7, and 8, you have to have the most vapor permeable class of membrane. But even then, is a class 4 vapor permeable membrane permeable enough? And I always ask the question, what's the most vapor permeable membrane you can get? Do you know what it is?
No.
Nothing. It's air. You just take the membrane out and the water vapor can go straight. Oh, but hang on. How am I going to weatherproof my building if I've got no membrane in there?
Yeah.
So now you've got this double-edged sword. I need to put a membrane in, but I need that membrane to be as vapor permeable as possible to allow the water vapor out. But also, if I drive the vapor permeability of the membrane too high, then I start to compromise the durability of that membrane. Because you can make them super vapor permeable, and I've done this around the world, but they super vapor permeable membranes had massive durability issues, which then in Germany led to failures of those membranes, which then led to water ingress or failure of the weatherproofing systems, which is actually worse than the condensation problem. But so this is the double-edged sword. So then you go, okay, I've got this membrane in there, it's vapor permeable, but it's as vapor permeable as it can get, but I still might end up with high humidity, condensation, mold behind that membrane, depending where I am in Australia. Okay, so now what do we do? We potentially got to go into a verification method. If we really want to get a good answer, we do a calculation on that, and we use the best tools we got, like the Woofy Pro software from Fraunhofer, and we have a look at that system in terms of the material layers and find out if we actually need additional vapor control layers in that system. And if you want to actually be certain that that system is going to be pretty close to zero risk of, I can't say zero risk, but close to zero risk of mold growth, then you need to have vapor control layers. And this is, well, why are we doing all this stuff? Why are we adding exterior membranes, insulation, interior membranes? Well, it all stems back to that cascade of intervention, which is we started insulating buildings. And these just slowly come, revision, iteration after iteration of the building code, until we end up with something that looks something like passive house. But so anyway, so that's why you might need to go down the verification method to actually prove or be certain that you're going to be building good construction systems that won't create risks of mold anywhere in Australia.
Gotcha. I think that's a good run through in terms of people understanding it, because it I've heard you say as well that you feel that everybody should be specifying a class 4 membrane, even in climate zones 4 and 5. You know, why is that you think that you should just go to that class 4? Is it because it's as vapor permeable as possible, but as
Yeah, so
yeah.
the class 4 is always the best option. You start with, I mean, Professor Hartwig Kunzel from Fraunhofer Institute first said this to me. He said, you need to make construction systems as vapor permeable as possible and only as vapor resistive as necessary. So vapor permeable as possible, and you make all the layers vapor permeable, ventilated cavities. Climate zone 4 and 5, they need it, because when I've done calculations using this woofy software, it's like, it's not good enough having a class 3 membrane. It's still showing up some risks of mold. So make it class 4. But even then, the next step is, well, it's class 4, but hey, have you even also considered you might need that internal vapor control layer as well? There's a lot of pushback. There can be a lot of pushback on the interior membranes. But if you really look into it and you start doing the calculations, it becomes pretty obvious that it's a good idea in almost all climate zones apart from the tropics.
Okay. I think it's really interesting because I know that a lot of homeowners, their heads will be spinning right now. They'll be saying to me, "Oh, there's too much, too much, too much." How do you actually suggest that they navigate and understand it? Because I find that a lot of them have to lead their team through it. They have to, their team will only know so much. Of course, there's loads of professionals out there that are all across this, doing a lot to upskill themselves.
Yeah.
But unfortunately, it's not the majority of the industry. And so there's still a lot of homeowners who, and it was why Undercover Architect was created in the first place, because I felt that if I educated homeowners, they would help elevate the standard of the industry overall, because they'd be demanding better. So, but it does become problematic for them because they almost need to be experts at this themselves in order to be able to have conversations with their team to kind of guide that through. The Pro Clima report, of course, is an amazing resource that they can access. Is there a no-brainer spec that they should sort of be discussing with their team, or how do they, like, always get a woofie done? That's just what we're going to have to budget for, so that we know that wall composition is going to work. How do they sort of do that without having to become ninjas at all of building wrap information and that kind of stuff?
Yeah, and you're absolutely right, because it is it's a difficult situation. It's like too much knowledge. I mean, I've experienced this. Too much knowledge ends up becoming a curse, because you know what can go wrong, and you're like, I just wish I was a little bit more ignorant and could just build what the building code says and be happy about it. I can't do that anymore. I can't just go build a building code building and it'll be all right. So you push down the route, and then I guess the standard. I mean, we've got a standard Pro Clima system, which is a timber stud frame wall. It is pretty typical in Australia, whether it's a fibre cement cladding, whether it's a weatherboard, whether it's a Colorbond mini orb on the outside. If you've got the ventilated cavity behind those claddings, a brick veneer as well. So you've got all those different cladding types, but you've got a cavity. Always have a cavity in there, drain and ventilated cavity. Then you just protect that insulated timber structure with an exterior membrane, class 4 vapor permeable. And if you use an intelligent air barrier on the inside, you don't need to do a woofie calculation. If you start to try and innovate, which I see a lot of architects or homeowners or anyone just trying to come up with new construction systems and different material layers in different positions, and you're like, well, if you're going to start putting continuous foam insulation in your construction systems, I'd say get a woofie done. High flag, like it's a red flag to say you start to put in these high resistance foam insulation types into your construction system. You need to know what you're doing, and so there is off the shelf solutions, the Pro Clima offer, which I'm describing. The WRB on the outside of the timber and the IAB on the inside. And that's pretty typical. So that fits into just a standard residential construction systems, or whether it's a roof system too. So cathedral and skillion style roofs are always the safest to build from a moisture perspective, because when you start getting into ventilated truss roofs, it's just so unpredictable in the way they operate, because the ventilation in the roof, it's much more predictable to have a closed timber structure, external membrane, internal membrane, insulation, fully filling the timber structure. Then you can predict what's going to happen when all those layers are airtight and sealed up. You can predict what's going to happen because you know where the water vapor is going to flow, and you can do a tuned woofie analysis to work out what the risks are. So there are off-the-shelf systems. We're always working towards better content, better information to make it easier for the homeowners and specifiers just to take that and run with it. It just takes time. But until then, we have to work together and potentially, get engineering calculations done using woofie when it's necessary.
Yeah. Can we just quickly, before we wrap up, just touch on the roof conversation that you just sort of opened there? Because I know that I get shown a lot of flat roof designs or very shallow pitch roof designs in the homeowners that I speak to and see their projects. And that's always, of course, a concern just in terms of its condensation management and the profile that they might be choosing, how thin they're making it, because often flat roofs are obviously very thin in profile. A lot of people are then going to use anti-con, which of course in its name says anti-condensation. So, a lot of people are doing that and not understanding that they might set themselves up for some issues. Equally, they're looking at making their roof space fully airtight and insulating into the house. And, so how do people need to think about their roof design, particularly in flat roofs, to ensure that they're not setting themselves up for problems over and above, some of the building code kind of stipulations?
I feel like that you might have got access to my computer and looked into the R&D pipeline. But we're soon to launch a new system, which is a skillion style, rafter style roof down to 2-degree pitch in Australia, which will include membranes on the outside, but full adhesive membranes over a rigid board, an intelligent air barrier on the inside, and a ventilated, counter-battened system above the membrane on the outside to hold the cladding. So it's always going to be a clip lock style roof, or one of those, long run profile metal things down at those low pitches. So it's a ventilated system. It's the same as the wall, but it's on a 2 or 3 degree pitch. And that essentially works the same way as I described for the wall. But those systems, we've had feedback from a lot of the architectural roofers using, standing seam roofs in Australia, that when you start to load rigid boards into behind a metal sheet roofing, they're having problems with those boards going mouldy and potentially rotting out. And that's why on those roof systems and the skillion really low pitch rafter roofs, you actually need that intelligent air barrier. And you're probably going to need it. Yeah, on the inside. You're going to need that in all climates, possibly just not, again, the tropics, so like the real top end of Australia. But the other thing to consider in roofs, and I should say this, is the colour of the cladding. Because you make white roofs, and I hope I don't get concrete boots for this, but you make white roofs, you will lower the temperature of the roof in summer, which is great, but you'll also lower the overall temperature of that roof in winter. And it actually increases the risk of mold, condensation, timber rot of the rigid sheeting boards in the winter months. So it's always, when you change a design parameter, you've got two sides of the coin. So designing white roofs are good for summer, but you also need to consider, is there a risk or an increased risk of moisture problems in the winter? And if you're going to start to do white roofs in Melbourne on this flat style roofs with long run metal, you really need to be careful about the roof color.
Yeah, I think that definitely is a climate exercise for people to analyze, because I know that a lot of the southern states, I speak to a lot of professionals because I've done a lot of, provided a lot of information in the past about how dark roofs are 70% of the sales, and we really need to move away from them due to the urban heat sinks that are causing, and the radiated heat and all of those kinds of things. And so, but I think that, and I've had lots of people in the southern states say, no, Amelia, you don't understand here. It's actually required for for winter warming for us to have darker roofs. And then it's, well, is the extremes that you're experiencing from a thermal point of view in summer, because you will get high extremes in your weather modeling with a dark
Mm,
roof. Do they counteract the benefits that you get in winter? But I think then also coupling that with an understanding of how that color might perform in the design that you've chosen for your roof, the
mm,
proximity that that metal sheet has to whatever the layer is underneath it,
mm.
and then what that means for condensation and mold growth. That
Yeah.
becomes, yeah, that's such a nuanced climate thing, isn't it?
Mm.
Because there'll be
And this
places
is
where it's milder climate that it's not such a drama in that
Yeah,
regard. So,
absolutely. Absolutely. It's a heat balance question. And the heat balance it's not a winter or summer discussion, which always frustrates me. And the reason and the building code, which talked about heat flow in, heat flow out, and designing R values for different directions of heat flow. So pretty much saying you're in a hot climate or you're in a cold climate, which is not true in Melbourne. Melbourne, you're stinking hot in summer and not too pleasantly warm in winter. It's a bit cold and brisk in the winter. So you need to design to make sure both those seasons work. And if you can design a light coloured roof with a proper ventilation strategy under the light coloured roof with proper vapor permeable membranes, vapor control layers underneath, and get it to work from a hygrothermal balance in winter, that's awesome because you get the best of both worlds. You get a light roof in for the summer performance, but you also have the proper systems in there to prevent the winter perverse outcomes. And that's what I would like to do: deliver systems that work in both seasons, not an either or.
well, Jesse, it's been fantastic having this conversation with you. I know I could keep going and ask, just pummeling with you with
Yeah.
questions, I imagine, but I want to make sure that I don't take up too much of your time. But yeah, I want to thank you so much for the expertise that you've shared and just being able to break it down for people to understand. I would really encourage the listening audience to check out the Pro Clima report. And what I love about the way that Pro Clima have run your distribution system, because obviously you've got a lot of builders that are suppliers and industry professionals that are suppliers of Pro Clima. So I find that there's, in terms of the ability to access detail information that you can then apply to your own project, is a lot more accessible. You're not having to ring the technical hotline of, a
Mm,
big supplier. You're actually getting to ring these individuals who are using this product, and then can give you kind of insights into how to best do it. And I also know, like, I mean, we're doing some work up in Brisbane at the moment, and the Pro Clima rep, Stuart Shelton, who's also a builder, he's actually coming to help the builder understand how this stuff gets applied and how to actually best install it, so you make sure it manages all the air tightness and everything like that. So it's been really fantastic to meet you and to speak with you, and I can't thank you enough for your time and just what you keep doing in terms of the information and knowledge that you put out into the industry. I really appreciate it.
thank you, Amelia. It's good to hear that the system that we set up is kind of working as it was planned. So it's great. Yeah, it's great to have all those distributor partner network with highly knowledgeable people that you can lean on. So please do, yeah, to all your listeners, please lean on our network of distributors and partners. Yeah, they're good people and have a lot of knowledge.
Fantastic. Thanks so much, Jesse.
Yeah, thanks, Amelia.